Section 8.3, Logarithmic Functions as Inverses. Today we're going to learn to write and evaluate logarithmic expressions. Okay, so you might be wondering what a logarithm is, and a logarithm is the inverse of using an exponential function. So it's something that we're going to use when we're trying to solve that equation that has the variable as the exponent. So we know what to do when the exponent is a value. If the exponent is squared, we can undo that by using a square root, or if it's cubed, we can undo that by using a cube root. But if the exponent happens to be a variable and we can't have a specific root to use, we're going to use a logarithm. So to do that, we need to kind of look at how the exponential form and the logarithmic form are related to each other. So I'm going to take these basic exponential expressions, and they all have values just to show you how this really is going to work. But so what a logarithm is going to do, it's going to tell me exactly what my exponent is. So you'll notice up here, when I show you this in its exponential form with the exponent being the variable, when I use a logarithm, I put in my information and it should tell me what the value of the exponent would be. Now I'm going to do these two examples, which we know all the numbers for, just to show you kind of how you would set this up. Okay, so here this says 25 is equal to 5 squared. And we'd all agree with that, that 5 squared is the same as 25. So if I'm going to put that into its logarithmic form, I'm going to start with, first of all, we're going to abbreviate that, as you can see, with the word log. Get a pen we can see here, log. And then this is going to be read log base, and we're going to be using the very base that we have in our exponential form. The base of my power is 5, so the base of my logarithm is also going to be 5. So this is going to say log base 5 of my value of my power. My power is equal to 25. So I'm going to say log base 5 of 25. And so what a logarithm is basically asking you is, with a base of 5, what power do I need to get 25? And so with a base of 5, I need a 2 to get that power. So log base 5 of 25 is equal to 2, because 5 squared would give me 25. Now we can do the same thing with the second example. We start with the word log, and we look at our base. The base of my power is 3, so this would be a log base 3 of the number that my power is equal to is 729. Okay, so what the logarithm would tell me, if I saw log base 3 of 729, I would be trying to figure out what exponent I could put on 3 that would give me 729. And in this case, I already know that's going to be 6 because of my exponential expression over here. Okay, as far as evaluating logarithms, we're going to use what we just talked about converting to its exponential form so that we can help figure out what this logarithm would equal. Because unfortunately, at this point, your calculator is not necessarily programmed to do base 8 logarithms, base 64, base 10, like I have the 3 logarithms here. So what I want to do is begin by taking my logarithm and writing it into an exponential form. So what this logarithm here is telling me, or asking me, is what power of 8 could I use to make 16? Now, I would try to decide if there's just an easy, nice power of 8 that I can use to make 16, but unfortunately there isn't. So I'm going to set up this problem, and it's going to say 8 to some power equals 16. Now, since 8 to the power doesn't necessarily nicely equal something with 16, I'm going to convert these or rewrite these into a format where they do have something that works together. So I'm going to write these both as a power of a number that is the same base. In other words, can I take 2 or 3 or 4 or 5 to a certain power and make 8, as well as make 16. And if you look through or think about all your different powers, 8 can be written as 2 to the 3rd power. So instead of an 8, let's put a 2 to the 3rd power there. And 16 can be written as 2 to the 4th power. So that makes my equation look like 2 to the 3x power equals 2 to the 4th power. And by getting those same bases, right, 2 to the 3rd power is still 8, just like I had here, and 2 to the 4th power is still 16. It's just a different form of writing that number. It's a way of writing it in an exponential form. So if the numbers are equal and the bases are equal, then that tells me that my powers or my exponents must be equal. So if I really want to solve this, all I have to do is set the 3x, the one exponent equal to the other exponent, divide by 3, so it tells me that x equals 4/3. So as far as log base 8 of 16, that would be equal to 4/3. If I take 8 to the 4/3 power, I will get 16. Now this next example, we're going to do the same thing. This one's asking me what power of 64 can I use to make 1/32. And one of the things you have to remember about things that are not fractions that become fractions or vice versa, if I'm working with exponents, that tells me that somewhere along the way I had a negative exponent. So you can expect that we're going to have to use a negative exponent in here somewhere. But let's set this up. So 64 to what power would we equal 1/32? So now again, just like the last problem, we want to find a base number that would not only make 64, but could also be used to make 32. And since they're both even numbers, I'm going to guess it's going to be something like 2 or 4 or something like that. And in our case, it's going to be 2. 2 to the 6th power is 64. So I'm going to 2 to the 6th to the x power. And 1/32 is 2 to the -5th power. Okay, 2 to the 5th is the 32. By making it negative is how it became the reciprocal 1/32. So then again, just like last time, well, let's see, that would be 2 to the power 6x equals 2 to the -5th. And just like in the last problem, if these are equal and their bases are equal, that means their exponents are equal. So I'm going to set 6x equal to -5 and divide by 6. And I'm going to end up with -5/6. So the exponent for this one, or the answer to this logarithm, is -5/6. Now this last one, let's set it up and see what happens. It says 10 to the x power equals 100. Okay, well this one actually is very simple. 10 to the x power, I can actually rewrite 100 as 10 squared. So that tells me that x equals 2. I actually know that if I take 10 squared, I get 100. So that one was very easy. Didn't even really need to get the same bases. I just know what power of 10 gives me 100, and that's 2. Okay, now the last logarithm I did had a base of 10. Now the base 10 logarithms are called the common logarithm. And these logarithms are the one logarithm where if you do not see a base included with the word log, you're going to assume that is a base 10. Now I would say that we have base 10 logarithms as the common logarithm because our number system is a base 10 system and we use a lot of things that are base 10. These are the ones that would be programmed into your calculator. So when you see that log button on your calculator, it's the base 10 logarithms. So like down here, in my example where it says log base 10 of 10,000 equals 4, I don't really need to write it that way. I can actually just say log of 10,000 and type that into my calculator like that. And when I do, my calculator will tell me that it's 4. So when you don't see a base on your logarithm, you need to assume that the base is 10. Just like on other things we assume, like when you see an x, it's x to the 1st power. Or when you see a square root sign, we know it's a square root, not a cube root, even though there's not a number there. It's just the most commonly used version of the logarithm. Okay, so for the last thing I want to do is this word problem here where they use logarithms in their formula. And this particular formula tells me that we use the common logarithm to find the pH of different substances. And if we know the pH, and we can find the concentration of hydrogen ions in our substance. So let's start the first example. Okay, so here's my formula right here. It says that the pH is equal to the opposite of the log of H positive, which that's just what they're using for our variable here. The plus sign doesn't really mean we need to do any type of operation. So they want us to find, they say the pH of the lemon juice is 2.3, and then we're also going to have to do milk. Okay, so I'm going to start with the lemon juice first. And as with any other formula, you plug in what you know, and then we'll see what we have left and decide how we're going to solve. So I know the pH of the lemon juice. So if the pH of the lemon juice is 2.3, that goes into my formula here, equals negative log of H plus. Okay, so I have two choices. I need to decide if my logarithm is already there and I can just calculate it, or do I need to rewrite it exponentially and do something with that? Okay, so when you look at this right here, this is a base 10 logarithm, but you'll notice I don't know the value here with my logarithm, so I can't just plug this in my calculator and calculate it. I'm going to have to do this. First of all, this negative here in front of the logarithm, we want to get that out of the way. So we're going to divide that. So we get negative 2.3 equals the log of H. Now, since I don't know anything about the log of H and I have to find this here, remember, this is the number that I get from my power. So the base of my logarithm is 10. The exponent is negative 2.3. So if I rewrite this exponentially, this is going to say H equals 10 is my base to the power negative 2.3. Okay, and that's going to tell me that H is equal to, we'll just go out to 0.005. Okay, so those would be the hydrogen ions in the lemon juice. Okay, so let's do the milk. All right, the milk has a pH of 6.6. So same process here, just a different number to start with. Negative log of H. Get rid of the negative on the logarithm so that I can use my exponent properly. And then rewrite this exponentially. Base of 10, right, common logarithm, power negative 6.6 equals H. So H is equal to, now mine's going to be in scientific notation, 2.5 times 10 to the negative 7, if you can see that I squished that on there. Okay, so you can use that. Now, if they give you the value of hydrogen ions, you're simply just going to be able to plug that common logarithm right into your calculator and calculate the pH from there.